Hey everyone, how's it going? This is Mr. Murray coming to you with a do now for March 25th, 2020 for Course 1 Honors. Okay, so in this do now, we're going to continue to do our work on solving equations, quadratics in particular. All right, and so last week the big focus was on using the method of factoring to turn a quadratic function from standard form into intercept form. And what we used that for then was to figure out how to easily solve equations, because we base this on the fact that if two numbers multiplied to be 0, just as factored form looks, then that means that each of those numbers is 0. So that let us set each of the factors to 0, and that is essentially how we solve the equation. Okay, and so in this video, we're going to continue to work on that. So what I want you to do, I want you to pause the video. I want you to try to solve these three equations. Again, thinking about what the right-hand side needs to be equal to. Okay, and then when you're ready, unpause, and I'll show you how to solve them. Alrighty, so here we go. I'm going to start with the first equation. 5r squared minus 44r plus 120 is equal to negative 30 plus 11r. Okay, and so what I'm going to do is I'm going to need to make the right-hand side equal to 0. So I'm going to add 30 to both sides to cancel out the negative 30. And I'll also subtract 11r from both sides. And when I do that, I've canceled out everything on the right, so there is nothing left, right? And nothing in math, right? Numerically, that means 0. So I take 11r from the 44r, give me negative 55r. And I'm going to go ahead and add, and that gives me 150. All right. And so immediately what I see is I've got a situation where a is more than 1. So what I'm going to try to do is I'm going to try to see if there's any greatest common factors. And as it turns out, there are. Okay. At this point, I know that 5 goes into r squared, 5r squared rather. It goes into negative 55r, and it goes into 150. Okay. So that leaves me with r squared, and then 5 times negative 11 would give me negative 55, and then 5 plus 30 would give me that. Now, do you have to do this? No. I guess you don't have to take out the greatest common factor. But you can see that by doing that, I've made the problem significantly easier, because what I know is that 5 times this stuff in the parentheses has to be 0. So either 5 must be 0, which it clearly isn't, or the inside, this quadratic, must be 0. So in other words, it tells us that all we need to focus on now is this, okay? And so what you could do is you could divide both sides by 5, right? That will cancel this 5 out, and it will leave me with 0 on the right. Remember, you can only divide when you have an equation. And now I just need to factor this one right here. So I'll set up my box. But because a is 1, this problem becomes a lot more straightforward. So r here, r here. And now I know that I need a negative and a negative, because a negative times a negative is a positive, and a negative plus a negative is a negative. And those two numbers I'm looking for are negative 6 and negative 5. All right. So essentially what I need to do is I need to solve r minus 6 times r minus 5 is equal to 0, giving me these two solutions. Either r is equal to 6 or r is equal to 5. Okay, and if I want to check my answers, 6 squared is 36. All right, 36 minus, this becomes 66. 36 minus 66 is negative 30. Negative 30 plus 30 is 0. 0 times 5, if you want to argue like that, is also 0. Okay, plugging in 5, 5 squared is 25. Right, 11 times 5 is 55. 25 minus 55 is also negative 30. And negative 30 plus 30 is 0. Okay, if I find two solutions, because I know my biggest power of r is 2, I know that there is not possibly going to be any more solutions than that. All right, moving on down to my next one. Okay, so this is similar. The main difference here is that now I've got to add something squared, so 5k squared. And remember what I said, this little adage I had. And remember, a negative a keeps wrong answers away. So note, I could have moved things over to the right. However, if I had done that, I would have ended up, so if I added 4k, I would have, or rather 4k squared, I would have ended up with negative 1k squared. And so I'm going to do it like this because 4k squared plus 5k squared leaves me with only 1k squared, which means a is a positive. And then the negative 3, that's actually going to cancel out on both sides. Okay, and so what I notice, I've got a common factor, so I take my k out. I get k minus 8. So either k is equal to 0, because I'd get 0 times negative 8, which is 0, or k is equal to 8, because I get 8 times 0, which is also 0. Okay, so just make sure we're on the lookout. We're on the hunt for 2 possible answers. But we could get less than that, just remember. All right, moving on to our last one. I've got 7r squared minus 14r equals 7. So again, I'm going to add the 7 on both sides, and that gives me 7r squared. Not to say again, but when I say again, I mean the idea of setting it equal to 0. All right, I'm going to get a similar thing here. Notice that there is a greatest common factor. I'll take that out. So that's 7. So 7 times r squared is 7r squared. 7 times negative 2r is negative 14r. And 7 times 1 is 7. And I noticed that this is a perfect square. This is r squared. And this is a perfect square. This is 1 squared. So let's try a difference of squares. I'm not saying it's a guarantee, but it's worth trying as our first guess. So this is a negative. So I'm going to need to try negative 1 and negative 1. So I get r squared minus r plus 1. And so it works. So 7, and I get r minus 1 is equal to 0. So in other words, 7 times r minus 1, because there are 2 of them, squared equals 0. And so that means that r has got to be equal to 1. So notice in this case, because the factors are the same, I only have one solution, right? And so some people would say, well, Mr. Murray, isn't it 1 and 1? But if you think about it, if you've already told me that 1 is an answer, you don't have to tell me again. I already know that 1's an answer, right? Okay? So this is how it breaks down. The big idea, again, with these quadratic equations is we want to make the right side equal to 0. That's the big idea. I know it seems like I'm pushing this hard, but the reason I'm doing that is you're going to thank me next year because, like I think I might have mentioned, next year we're going to talk about a formula that's going to get us these answers real quick. But if you don't make it the quadratic equal to 0, the formula will not give you the right answers. Okay, so hopefully you found this video helpful. I hope you actually got the same answer that I did. If so, congratulations. If not, I definitely recommend you take another look back at this. But hopefully you're able to get through today's lesson. You're able to stay caught up. I'm looking forward to the Hangouts in a couple more days. So keep up the good work. Don't forget to love math. All right, and remember, you can do it. All right, thanks again for watching. Don't forget to like or subscribe to stay up to date on my videos, and have a wonderful day.